my name is Nelson Karaoke, and today I'm going to be talking about the concept of Riemann sum and Riemann definite integral. So let's begin. Riemann sum is used to estimate the area under the curve. Consider the curve y is equal to f of x. So this curve y is equal to f of x defined over the closed interval a, b. So the closed interval a, b. To estimate the area under the curve, divide the closed interval a, b into n sub-intervals. So for example, x0 and x1 is a sub-interval, x1 and x2 is a sub-interval, and xn minus 1 and xn is also another sub-interval. Each of uniform width delta x. So delta x is the space between two endpoints. For example, the space between x1 and x2, and it is equal to b minus a. So and the endpoint b minus a over n, which is the number of subintervals. So let the endpoints be x node, which is equal to a, x node, which is equal to a, x1, which is equal to a plus delta x, x2, which is equal to a plus 2 times delta x, all the way to xn, which is equal to a plus n times delta x, which is also equal to b. In each sub-interval, choose a point x star 1. So between the endpoints x0 and x1, choose a point x star 1. Between the endpoints x1 and x2, choose a point x star 2, all the way to xn minus 1 and xn, choose a point x star n to be the height of each sub-interval. So in this case, I am using the middle ordinate or midpoint Riemann sum because it tends to give a better approximation than the left endpoint, which is an underestimate, or right endpoint, which is an overestimate. So this means that, for example, the point x star 1 is exactly at the middle of x0 and x1. Then the area under the curve is approximately f of x star 1 times delta x plus f of x star 2 times delta x, all the way to f of x star n times delta x. And since delta x is a like term, we can rewrite it as delta x, open the brackets, f of x star 1 plus f of x star 2 all the way to f of x star n. And we can further simplify it to delta x times the summation of f of x star I, where I is from 1 to n. So that is the Riemann sum. Let's go to the Riemann definite integral. For a better estimate of the area below the curve, increase the number of sub-intervals n. So let's go back to our diagram. For a better estimate of the area below the curve, increase the number of sub-intervals n. So when you increase the number of sub-intervals n, this means that n will tend to infinity. So that is, the area is equal to the limit of the summation of f of x star I times delta x, where I is from 1 to n as n tends to infinity. Then this area will be equal to the definite integral of f of x from a to b. As the number of sub-intervals n tends to infinity and the width delta x tends to 0, the Riemann sum approaches a limit equal to the exact area under the curve, which we can calculate using the fundamental theorem of calculus. That is the definite integral of f of x from a to b. So that has been the concept of Riemann sum and Riemann definite integral. I hope you have a better understanding. Thank you so much.